Hi everyone, welcome back to Physics 11. So in this video I'm going to go over one of the questions from 8.3 on circuit analysis, so question number 15. Now question number 15 is a little confusing mostly because the way it's labeled. So if you ever find that you're not sure what the question is asking you, try to redraw your diagram so it's easier to understand and relabel it if you need to. So that's what I've done in this question. So the question asks to find the values for current I1, I2, and I3. So what I did is I redrew my schematic, my circuit schematic down here, and then I relabeled it. So current total is going to start from here, right? It's going to flow through R1, so it's going to be my I1, which is going to still the same as I total because this is in series. And then it's going to split at this node right here. It's going to split into I2 and I3, and then it's going to combine again at the next node here into the I total, which is in the original diagram is labeled as I3. So I need to find the current that I highlighted in my redrawn schematic. So that's the first step. Once you do this, the question should be pretty straightforward. As you can see, we have one resistor in series with the two resistors there in parallel. So before you start doing any math, before you start writing any of the laws, look at your diagram, look at the current. You know that the current in series, they have to be the same. That means that your I total is going to equal to the I1 through resistor 1, because again these two are in series. There's only one path for the current here, so these are going to be I1, so these are going to be exactly the same. And then I total is up here, which is one of the parts that we need to find. These are going to be exactly the same because this is in series. And then this is going to also equal to the sum of I2 and I3, because if you treat these two resistors as just one resistor, if you add them, then the current of these two will have to add to the total current or to the I1. So you can say that I1 equals to, you can say I2 plus I3. So you have to understand that part. Now, we can find the I1 or the total current because we know the value for resistor 1, and we know the voltage as well here. So let's see what else we know about voltages. We also know that once you know the total resistance, so let's add these two parallel resistors together. So these R2 is in parallel to R3. So let's do the sum of these two. So R2 plus 3 is going to equal, well, I should write it over 1 over R2 plus 3, because again these are in parallel. It's going to be 1 over R2 plus 1 over R3. So this is going to equal, the way I labeled it is going to be 1 over 2 all right, so that's going to be our 1 over R2 plus 3. Again, use your calculator, use your fraction button. So 1/2 plus a quarter, we get 3/4. So 1 over R2 plus 3 equals 3/4. Now we have to reciprocate both sides, so we get our parallel resistors equal to 4/3, or 1.3 repeating. Okay, so that's going to be our R2 and R3 added together. Because they're in parallel, we have to go through the reciprocal there. Okay, once you know those two resistors added together, we can find the total resistance by adding the R1 to it. So we can say then R total is going to be R1 plus the R2 plus 3, which we just found the value for. So this is going to be 6.0 plus 1.3 repeating, which is going to be 7.3 repeating. That's going to be our total resistance. Once you know your total resistance, we can find the total current using Ohm's law. So So we can say that the total current is going to be the total voltage over the total resistance. Now the voltage is already given. V total is 20 volts, so 20 divided by 7.3 is going to give us the total current, which is going to be 2.7 amps. So that's going to be our I1 and also our I total. So that's where we get this one and that one. So again, because I total and I1 are exactly the same because these are in series, you get those two currents right away. So that's first part of this question. Now we still need to find the I3, which is right here in the middle of this parallel resistors. Now this one requires a little bit more work because we need to know the voltage drop across these two parallel resistors. So for that we need to find the voltage at that point. Okay, so we know our resistors, we know our two currents already, and what we need to know is the voltage drop across the first resistor, and then we can subtract it from the total voltage to get the voltage across R2 and R3, because these two are in parallel, it's going to be the same. So we can say that, what can we say? We can say that the total voltage is going to equal to V1, which is going to be across resistor 1, plus V2 or V3, because R2 and R3 are in parallel, the voltage across these two is going to be the same because these are in parallel. So that's why I wrote V2 or V3. Now we know V total already. We can find V1 because we know R1 and we know the I1. So we can find our V2 or V3 by basically subtracting. So we can say that our V2 or 3 is going to equal our V total minus our V1. So let's plug in the values for this. So V total is 20. Okay, so let's just write 20 minus V1. Well, V1 is going to equal to the I1 times R1, which we already know. So let's plug in the value for that as well. So I1 is, we found it to be 2.7, and R1 is 6 ohm. So let's see, this is going to give you 3.8. So that's going to be your V2 or V3. And once you know that, then you can find the current across the R3. So let's find our current I3. So let me switch to red for current. So I3 is going to equal to V3 over R3. Now I just found my V3. I know my R3 already. So this is going to be 3.8 over 4. So this is volts, this is ohms, and this is 0.95 amps. Now the answer key shows up as 0.91, so it's a little off. I'm not sure why. So I didn't make up this question, so I'm not sure why that is, but that would be the answer for I3. So there you go. Those are the three currents. So again, the total current and the first I1 are exactly the same, and then I3 is this one. You can also find the I2. The question doesn't ask for it, but you could find it because you know your V value, which is, again, it's going to be the same, 3.8 over, in this case, 2 ohms. So that would give you 1.9 amps. And again, we can check whether this is right or wrong, because remember, these two currents should add up to 2.7 amps. So 1.9 plus 0.95, that adds up to 0.85. So let's see, I might have omitted so I think what happened here is because of the rounding, the answer is a little off. So I think if you recalculate V2 or V3, or even starting the here for the total current. 20 divided by 7.3, that would be 2.739. I think the only issue here is rounding. So the reason these are not adding up to exactly the same 2.7 is because of rounding, because these values here, the 2.7 and the 3.8, they're off by a few decimals. I think if you keep just one more decimal, you should get the same answer as the answer key provides, 0.91, and then it should add up to the total 2.7. But the steps should be exactly the way I've done them in this question. Okay, so again, in this case, if you're confused about the diagram, if you need to relabel it, feel free to do that as long as you're clear what you've done. So if you relabeled any of the values, just make sure you find the values that now you're looking for. For example, here I renamed them a little bit, and I was looking for I3 up here because I just like to label it the same way as the resistor. So if this is R3, I want to have my I3 there, and if this is R2, I want to have my I2 there. All right, so that's question number 15.